So, what is attracted? So we're in chapter 3. This is the beginning. We're going to watch this little YouTube video. Try putting on the volume a little bit more.
This is the story of the alkaline metals who were trying to get rid of electrons. All of them had one in their valence, and they wanted none. This is the story of another family. Group 17 were also known as halogens. 7 electrons were in their valence, and they wanted 8. Till this one day when the metal met the other, the electron transferred to the halogen. Both of them got charged and were attracted. That's the way they became ionic bonds. Ionic bonds. Ionic bonds. That's the way they became ionic bonds. Ionic bonds. Ionic bonds. That's the way they became ionic bonds.
Okay, so that was an intro real quickly to what we're going into. I know it was a little lame, but that's okay. So, I'm going to just turn up the, oh, I'm doing the zoom. No wonder the volume was bad. Forgot to put the volume up. Okay, so in your study guide, we're going to go through things. So this is an introduction to bonding. They've actually split it into 2 sets. Bonding is basically a joining of electrons in the outer shell to make a stable arrangement. When it's talking about a stable arrangement, they want to gain or lose or share electrons to reach an electron configuration where they're like a noble gas. Okay? So, definition of bonding. Basically just getting electrons together from one element to another. Okay? Going forward. Please. PowerPoint is not loving me today. Okay, we're going to go this way. You're going to see a preview of what we're doing on the right-hand side, but that's okay. So, there are two different kinds of bonds, basically ionic and covalent. Ionic result from transferring the electron from one to the other. Covalent, they actually share. Okay, so we're going to watch a little video on this that will help you understand it.
Welcome to Dogs Teaching Chemistry. Our first lesson is chemical bonding. Chemical bonds are what holds atoms together. A chemical bond is an attraction between atoms that allows the formation of a chemical substance. The electrons that participate in a chemical bond are called valence electrons. These are electrons that are found in an atom's outermost shell. Let's take a look at the types of chemical bonds that can be formed between atoms. An ionic bond is formed when one of the atoms will lose its electron to the other atom. This results in a positively charged ion, called a cation, and a negatively charged ion, called an anion. Positive and negative attract, and the result is an ionic bond. Covalent chemical bonds involve the sharing of a pair of valence electrons by 2 atoms. There is also what is called polar covalent bonds. These are covalent bonds in which the sharing of the electron pair is unequal. The result is a bond where the electron pair is displaced toward the more electronegative atom. Thanks for watching, and we'll see you guys next time.
Okay, it was a little silly, but it gives you the basic idea. So let's go on to talk about ionic bonds that form between a metal and a nonmetal. So if we remember the staircase between boron and unoctium, below that staircase and to the left on the periodic table are your metals. Above that staircase and to the right are your nonmetals. So in order to have an ionic bond, you have to have a nonmetal and a metal. Okay, that's like taking sodium metal and mixing it with chlorine gas. You would get salt, which is an ionic compound. And there's actually a YouTube video, if you Google it, salting your popcorn chemically, where he actually puts the chlorine gas and the sodium metal together, and then he has an ignition switch that gives it a little spark of energy, and he salts his freshly made popcorn. Okay, as we look at ionic bonds, you can look at it several different ways. There's 3 different ways up here listed. You can do it visually, just looking at the outer shell electrons here, where you can see that it's changing one from sodium to chlorine, and sodium becomes positive and chlorine becomes negative. You can actually show the electron moving from one to the other. You can actually show it already moved with the cation and the anion. So here's another little funny. I'm a nonmetal, I'm a metal. Together we're like rock solid, sparks fly, and with a lot of electricity. We break up, losing all energy and electrons to make ourselves solid again. So, going forward, a covalent bond is made when they're sharing, and it has to be 2 nonmetals that are sharing, or a metalloid and a nonmetal. It can't be a metal. What we get is what's called a molecule. So a molecule is what we get when we have covalent bonds, whereas an ionic compound is what we get when we get ionic compounds. So, what is an ion? An ion basically is a charged species. We know we cannot change the protons. If we change the protons, we change the element. If we change the neutrons, we just get a different isotope of the same element. But if we change the electrons, we change the charge, and that's where we get ions. And ions have to be opposite to be able to attract for an ionic compound. We call it an electrostatic attraction. So think of when you take a balloon and rub it against your sleeve of your shirt to get it to stick. It gets static, so it's electrostatically stuck to you. That same thing happens with elements. Okay, there are basically 2 types of ions, and they talked about them in the video. You have your neutral atom to start with, and that's where your protons are equal to your electrons. Then, if you lose electrons, and if you lose weight, you become more positive, right? That's called a cation. And the way I remember the cation is cats have paws, and it's positive, because I've lost I lost electrons. The electrons are negative, and I'm losing them, so that's a good thing. I become more positive. Or I've lost weight, become more positive. On the other side, when I gain electrons, I become negative, because gaining pounds for a woman is very negative. Okay. It also looks like onion. Okay, anion looks like onion that can make you cry, so you could use that way to help remember. That side has more electrons than protons, so it's going to be negative. So anions are negative. So if we look at, let's see if I can get this working again. Nope. Yep, maybe. So if I compare atoms, here's my sodium atom. If I then take and draw the electron configuration for that, and I've put each color as a different shell out from the nucleus. This green shell is the outermost shell, and there's only one there. If I take that one away in the outer shell, then I can go to move to what's known as a sodium ion. That outer electron, 3s, is no longer there. But you'll notice the 2s and 2p, the 2 and the 6 add up to 8. And because they add up to 8, it's like a noble gas. So this sodium cation is what we call isoelectric with a noble gas. So isoelectric just means the outer shell is like a noble gas. Okay? If I take the chlorine atom here, and again, black is the first shell, blue is the second shell, red is the third shell, it's missing 1. It only has 7 in its outer shell. So it wants to get to 8 like a noble gas, so it's going to need to gain 1. When it gains 1, it has a negative charge. Remember, gaining is negative as far as gaining weight. But in the outer shell, it has a 2 here, and it has a 6 here. And it has 8 electrons in the outer shell. So what I'm trying to do is get to an isoelectric with a noble gas. So the same outer electron configuration as a noble gas. So metals like sodium will become cations, which are positive. So on the bottom left of the staircase, they're going to be positive. That's because they want to lose 1, 2, or 3, sometimes 4 electrons to form what we call a cation. Non-metals above the staircase will become negative, or anions, because they will tend to want to gain an electron to become like the noble gas right by them. One thing that you need to remember in either way of this is the octet rule. The octet rule tells me I want to get to the noble gas. I want to have 8 in my outer shell. The only exception to this is the first row, which has hydrogen and helium on it, because there's only 2 there. So to be like a noble gas there, I only need 2 in my outer shell. Okay, so looking at the main group atoms on the, yes? Yep. If I go too fast, let me know, because I'm just clicking over here instead of walking like I usually am because it's being dumb. I might get up and try it and see if it'll work here in just a second again, because it's starting to work here with the mouse. We good to go forward? Yeah. Okay. So if we look at the periodic table, ignore the D, ignore the F. Okay, ignore the D, ignore the F. You can basically say what element's main charge is going to be. If it's in the first column, hydrogens and lithiums, it's going to be a +1. Second column, +2. Skip the D, come over to the third column, boron's column, it's going to have a +3 as one of the charges. Carbon's column is halfway to 8. Because it's halfway to 8, it can lose 4 or gain 4 to get to 8. So it's usually a + or -4. Nitrogen's column, usually -3. Then oxygen's column's 2 away from being a noble gas, so it'll gain 2 to be -2. And fluorine will gain 1. So as we look at this, elements of the same group have similar charges. For metals, 1, 2, and 3A, which would be 1, 2, and 13 on our periodic table, because we don't have them in A and B. That's an old system. Those would be according to the column they're in if you take away the 10 for the noble or for the transition metals. For the non-metals, nitrogen, oxygen, and fluorine's column, notice hydrogen is included here because hydrogen's sort of funky. It can go +1 or -1. We just take whatever group number it is and how many does it need to get to the noble gas. So here I am, I need 1 more to get to a noble gas. Here I am, I need 2 more to get to noble gas. Here I am, I need 3 more to get to noble gas. That's where we get the charges. So relating up to the group number 2, what's actually happening? So in group 1A, you have 1 valence electron. So you start here with an atom and you have 1 valence electron. So 1 electron is taken off and you leave the metal with a +1 charge. This is the alkali metals. So lithium's column. Group 2, Group 2, we have 2 valence electrons. So we're going to take 2 electrons off and leave it with a 2+ as a charge. This is beryllium's column. Group 3 is boron's family, and it will give off 3 electrons, leaving you with a +3. Now, as you go down each column, some of them have more charges than that because as they get bigger, they really don't care to actually be a noble gas or not. As we look at the ones that are closest, by the way, that should be a 7A right there, so pretend like that's a 7. Group 5A, 6A, and this should be 7A, has 5, 6, and 7 valences. You'll notice that the electrons now move from the product side, which was over here, to the reactant side. I need them to create the nonmetal ion, which is the anion. Okay, so I have to add them together to get there, where the other one was taken away. Yes? So it's basically just the first column on the periodic table, the second column on the periodic table, and group 3A is actually group 13, which is boron's family. And same thing here, 5A is nitrogen's family, 6A is oxygen's family, and 7A, which one should be 7A, is the halogens. Okay, so there are some other metal ions that you need to know, and I did put those on the top of the page for you. I don't have you having to write any of them down, but those are ones that you do need to know. So if you don't know them, when you go to get on the test, it would be a good idea to put them on your periodic, or on your 3x5 card. Okay, so now we're going into talking about common ions in the human body and how they're used. So as we look at the human body, the first one that we're going to look at is Fe. Fe is present in hemoglobin in the blood. It helps us transfer oxygen around. If we didn't have Fe plus 2, we would have a problem. Now the problem with Fe plus 2 is it really quickly degrades into Fe plus 3. It only has a life of about 12 hours. So when we use it in lab, I have to make it up that morning. That's a problem if your body needs it, because it needs a constant supply of it. So when you see cereals that say iron fortified, what they've actually done is they've taken iron filings and put it in your cereal. The reason why is when that iron filings hit your stomach acid, it turns to iron 2+ that your body can use. If they put iron 2+ in the cereal, by the time it got to your body, it would be iron 3+, and your body wouldn't know what to do with it, and it would just pass through. So that's sort of an interesting little side note. You also have chlorine ions in there. That's with your gastric juices and stomach and other fluids in your body. And sodium and potassium are also found in all body fluids, and they help with regulating. Calcium is found in teeth and bones, and magnesium is needed for nerve transmission. If you've ever had a muscle twitch or an eye twitch, this is telling you probably are low on magnesium or potassium. So if you've ever run a marathon, I know that the dirty dash that they do up in Soldier Hollow, they give you bananas at the end, and that's because you need that so you don't get cramping after, because of the potassium. Okay, so major cations in the body that you're responsible for are sodium and potassium, calcium and magnesium. Potassium and magnesium are present in high concentration inside a cell. So they have to be inside the cell, and they're high in concentration there. Sodium and calcium work outside the cell, and that's where they're high and where they do their job. Most important is, a lot of people say, oh, I've got to watch my sodium intake. Most people in the American diet consume 3 to 5 times the amount of sodium they need, but are actually low in potassium. So they're lacking in potassium. So you have to make sure that you're getting the right things. The people that have heart disease and heart problems have to watch both sodium and potassium, especially if they're in heart failure, because potassium levels go up, your body doesn't know how to process things. Other ions that are important are your Fe plus 2, which is used, like I said earlier, to transport oxygen through red blood cells to the rest of your body, and chlorine. Chlorine is actually really important in your gastric juices. This is where we have the hydrochloric acid in our stomach. It also helps with regulating how much water our bodies retain. If we have too much chlorine and potassium and sodium, our bodies will tend to be thirsty, and they'll tend to want to keep the water, to dilute it to the solution that they want. And people with heart disease, that's what's happening, is they're keeping too much water. So they often put them on water pills to make the water come through rather than store. Okay, so we're going to go through this really quickly and review real fast Lewis diagrams. As you're looking at the periodic table, any element in a column is going to be the same. So group 1 would be your lithium's column, and you just put 1 dot there and done. I'm going to change this to black. In the second column, you have 2 outer shell electrons, so it's going to go here and here. And when I'm talking about outer shell electrons, I'm talking about on that row, the S and P to get to that element. I ignore the D, I ignore the F, it's just the S and P on that row to get to it. Okay? So group 13, I've ignored the D, so I take 10 out of the D, and it would just be row 3. Right? Or column 3. So I would put 3, and 3 would be in a triangle because electrons are negative and they repel each other. They want to get as far away from each other as possible. That's why the 2 went opposite. When I get to 4, I actually have 1 on each side. When I get to 5, I've now got one on each side plus another one up top. When I get to 6, I just keep going around. So start at the top, come around. I've got 4, 5, and there's 6. Then when I get to 17, it's 7. So 1, 2, 3, 4, 5, 6, 7. And when I get to 18, it's 8. And I know there's 2 on each side, so I didn't fill it the same way that I did the others. Okay, so octet rule again. I want to have 8 or 0. Okay, and 0 would put me down to the one below it. So exceptions to the rule are hydrogen and helium. We already talked about that because on that top row, there's only 2 across, so I can only have 2. Okay, so hydrogen and helium are the exceptions. I want you to try really quickly now to draw the Lewis dots as fast as you can for these elements. You'll want to get your periodic table out because we're going to be using it. So if you haven't got it out, get it out. I'll give you a 30-second head start. And let's see if you can beat me. 30-second head start. Actually, I'll give you a minute because you all didn't have your periodic tables out. As fast as you can. Okay, I gave you a little bit of head start. I'm going to start. Hopefully you're hurrying. Anybody beat me? Oh, yeah. Okay, did you get them all right? Yes?
Does it matter if the 2 sets of dots, like when there's 2 on one side and 1 on the other, does it matter if the set of 2 is on the right or the left?
It's for oxygen?
Yeah.
As long as the 2 they're not opposite each other. Because if you do them opposite each other, like 2 on the top, 2 on the bottom, it's harder to see the shape. It's still correct, but it's harder to see the shape. So that's why I teach you to do it this way. Okay? All right. We're good to go on? All right, let's move. All right, so when we look at an element, we need to be able to, in our mind, visualize that Lewis dot. Okay? So calcium, I'm just going to draw it. Calcium would have 2, right? Is it closer to 8 or is it closer to 0? It's closer to 0, so that means I'm going to get rid of these 2 electrons. When I do that, it becomes Ca2+. I could also write that this way. Ca goes to Ca2+ plus 2 electrons. Okay? And we'll be using that kind of verbiage later, so that's why I'm showing you both. So fluorine has, we did it on the other side, 7 around it. Is it closer to 8 or 0? 8. Because it's closer to 8, it's actually going to gain an electron, right? And if it gains an electron, it becomes positive or negative? Negative. So we end up with F minus. And so we would write over here, fluorine plus an electron yields F minus. This one would be a cation. This one would be an anion. Okay? Quickly do the last two. Just like what I did. I'll walk around the room and then I'll quickly put it up. I'll give you a head start. So do both of them. How'd we do? Thumbs up, I got this. Thumbs down, I don't. Thumbs down, I'm sort of there, but not really. I see half of your thumbs. Okay, let's keep going. Hopefully it'll click in. So, as I'm looking at this, now I'm not going to write it. I've just got to think it in my head. So looking at your periodic table, remember I told you we'd be using your periodic table, so make sure you had it out. Okay, looking at your periodic table, find oxygen. How many does oxygen need to give away or take in to be like a noble gas? 2. Is it taking in or giving them away? Taking in. So is it going to be positive or negative? Okay. Is O minus isoelectronic with a noble gas? No. So we're going to cross that out. It's not isoelectronic. Okay. Find lithium. It's in the S. Okay, how many does it need to give away or gain to become a noble gas? Give away 1. Since it's giving away 1, what charge will it be? Positive 1, which this is. So this is isoelectronic with a noble gas. Okay, go on to sulfur. Where's sulfur at? Okay, how many does it need to gain or lose? Gain 2, so it's going to be a what? Positive or negative? Negative, which it is. So this one is isoelectronic. Okay. Find aluminum. How many does it need to gain or lose to become like a noble gas? Lose 3, so it becomes what? Positive or negative? Positive. So we need 3 here. We only have 2, so that is not isoelectronic. Okay, find nitrogen. Now I'm not going to walk you through this. You guys just tell me yes, thumbs up, or no, thumbs down. Is it isoelectric or not? Yes. It is. Good. Okay, what about Cl+? Thumbs up, yes. Thumbs down, no. You're right. Okay, what about bromine negative? Okay, can you see how fast this is now going into your brain? You can really just look at the periodic table and see how many it needs to gain or lose, right? Okay, so going forward, we need to be able to just look at a group number and be able to predict what charge it's going to be. So looking at group 2, whose group is that on the periodic table? Berylliums. It should be berylliums. What charge? +2. Good. Looking at group 15. What's in the top of that column? 15. Nitrogen. Charge. -3. Needs 3 more to become a noble gas. Group 17. -1. It's top of fluorine. Group 13. +3. That is aluminum's group. So you should be able to just look at the group number and give me a charge. Okay, what the most common charge is. That's not saying that other elements in that group won't have other charges. That's just the most common. Yes? Do you have a question or you just, okay. All right, so we're going to look at an ionic bond formed when a metal transfers one or more electrons to a nonmetal. The sum of the charges always has to be an overall 0, okay, for an ionic compound. When we get to, we'll have some things later that will have a charge. So basically, here we have magnesium, and it has 2 of these electrons in its outer shell that it wants to get rid of. And chlorine really wants to move them right here, okay? So when it does, magnesium becomes a positive, what was that name? Cation. Remember, cats have paws. So positive cation, and the chlorines become a negative anion. Okay? They are electrostatically attracted to each other. They're not actually bound. There's no actual bond there. It's just an attraction, sort of like a static electricity. Okay? All right, so opposites attract, and you need to remember that opposites do attract when we're working with ionics. The opposites will bring together, and they'll sort of clump together and bounce each other's charges. So when we write them, we usually write them either with a plus in between them, or we write them in brackets next to each other like this. Okay, so how do we write the formula? We've now talked about what's going to happen. How do we write it? We need to make sure the overall charge is 0. Whenever we need 1 of something, we don't write a subscript as 1. But if we need more than 1, we do write the subscript. So here we start with calcium and chlorines over there. Calcium has 2 electrons. Chlorine needs 1. So I'm going to need to use 1 of those for one of them and 1 of them for the other one. Okay? When I do that, calcium now becomes a calcium +2 ion. It's going to shrink in size. Chlorines will become a chlorine minus ion, and they'll actually grow in size. Okay? Cation, anion. Calcium is a cation. So we need 1 of these calcium ions for every 2 chlorine ions, okay, to get them all to the noble gas. So we could say it for each calcium +2, I need 2 chlorine minus. So in other words, 2 plus 2 times a -1 equals 0. That's what we're doing. Okay? Now, to say that, we need to be able to write the formula. Always positive first. Okay? So if you got bad news to tell somebody, you got good news, always tell them positive first. Okay? They're in a better mood. You put it together like this. So 1 calcium, 2 chlorines. And that's how we would write the formula. We would also show it something like this graphically, where they're attracted. Now, remember, the calcium had the electrons on the opposite side of each other, so when the chlorines come in, that's where they're going to come in, because that's easier for them to grab. They're not both going to come in on one side. Does that make sense? Okay, so let's try this. Magnesium and oxygen. If we drew what magnesium-oxygen looked like, it would be like this. So this one right here would end up right here. This one right here would end up right here. And when we did that, magnesium would end up with a +2 charge, and oxygen would end up with a 2 negative charge, right? Let's do some on our own. Okay, lithium. How many electrons does the lithium have around it? 1. How many does oxygen have around it? 1, 2, 3, 4, 5, 6. Okay, well, I can see 1 lithium can go right here, but that doesn't satisfy oxygen. So what am I going to need? I'm going to need 2 lithium. So I'm going to put another lithium over here, take its electron, and say it's going to go right here. Okay? So on this next grid, I'm going to just put, I have an Li with a positive charge. I have an oxygen that's in the center that has 8, and it has a 2 minus charge, and then we have another lithium on this side that's going to have a plus charge. Right? So they're attracted. So the chemical formula, what's the chemical formula going to be for this? Li2O. So I do a subscript. Positive first. Okay, let's do calcium. Calcium has how many around it? Probably ought to put it in the center. Calcium has 2, right? And then we have chlorine. How many does chlorine have around it? 7. 1, 2, 3, 4, 5, 6, 7. And I know one of these is going to go here, but I still have one left. So I need to make another chlorine. So another chlorine comes in right here. I'm going to do it backwards so it'll go in easier right here. And I can say this is going to go right there. Rewriting it with the charges. So Cl is going to have 8 around it with a negative charge. Calcium isn't going to have any around it, but it's going to have a 2 plus charge. And you're going to have another chlorine over here with 8 around it. That will have a negative charge. So my formula is what? Ca, Cl2. Good. Going with the next one, aluminum. How many does aluminum have around it? 3. I heard it. 3. And then we have phosphorus. How many's phosphorus got around it? 5. That's correct. So we're going to easily be able to move these, one right here, one right here, and one over here, to make phosphorus have its 8. But aluminum is going to have a 3 plus, and when I draw phosphorus, I'll have 8 around it, and it'll have a 3 minus. Those still add to equal 0, so what's my formula? ALP. I just need one of each, right? Okay, next one, sodium and chlorine. So sodium, Na, 1 dot. This one's easy, right? Chlorine, 7th column or 7th group, so it's going to have 7 dots. I'm going to put the lone one over here on this side so it's easy to show. It's going to come in. We're going to get Na plus, Cl with 8 around it, with a minus, 1 of each, NaCl. Go ahead and do the bottom one by yourself, see how you do. I'll give you a chance to do it. How do we do? Yes?
If you were to write it PR2,
That would be wrong. Positive's always got to go first. Good question, though. Okay, so always writing my positive first. Okay, going on to the next page. There are some polyatomics. If you look at the back of your periodic table, I also have on the back of your periodic table a nice chart of polyatomics for you. These are groups that hang together on the periodic table and have a charge. So these are elements that hang together and have a charge. if you'll notice, there's only one on here, up here, that has a positive charge. There are gangs on the periodic table that have a positive charge, but they're not very few. They're few and far between. So ammonia is one of them that you'll need to make sure you know. The others all have negative charges, because what the word gang, it has a negative connotation. Just remember, it's going to be negative, because it's going to have gained some electrons from somewhere else. Okay, so we're going to be using this. I'm going to show you a real quick trick to remember about 40 of them. And if you can get this trick into your brain, great. If you can't, you got a 3x5 card. Okay, so here's the trick. Looking at the periodic table, if you add to the ones that are in this, what I call the upside down L, except for iodate, okay, if I add 3 oxygens to them. Now notice I didn't add 3 oxygens to oxygen. Well, that would be stupid, right? Oxygen with 3 oxygens is still oxygen. And I didn't add it to fluorine. And the reason I didn't add it to fluorine, fluorine's sort of very ornery about sharing. She doesn't do it at all. She wants your electron, she'll rip it off you. Okay? She's very forceful. Okay? But I've added 3 to this. And then the column P and S and iodate, because iodate's by itself, I add 4 to. Okay? PS, by the way, they're special. They do everything special. Everything is about them. On the periodic table, they always get extra stuff. So just remember that. PS, by the way, they're special. They get 4. At this stage, I knock out oxygen and fluorine, because they don't, when I add oxygen to them, it doesn't work, because oxygen to oxygen. I take this top row and I slide it over. So I'm going to drop that out and I'm going to slide it over. When I do that, okay, do you notice anything about the charges in the columns? They're all the same. 1 away from the noble gas would be -1. 2 away would be -2. 3 away would be -3. So that was really quick. That's 10. Okay, if I remember they end in 8, and I did the upside down L as 3 with iodate having 4. PS, by the way, they get 4. Then I've got 8 that I can name real quickly. Now, here's the trick to get the other 30. So another 10 you can get by saying, okay, if I take 1 oxygen away from what that is up there. Well, if somebody takes something away from me, I want to fight. I want it back. Don't you mess with me, right? So I change the ending from 8 to I, like fight. Okay? So it would be like SO3 would be sulfite. PO3 would be phosphite. ClO2 would be chlorite. NO2 would be nitrite. Okay? Now, if it goes farther, so somebody comes and they take my car and they take my house. And it's wintertime. And I'm out in the cold. And I'm going to get hypothermia, right? This is how I remember it. So if they've taken 2 oxygens away, I now put that hypo in front of the ite. I still want my stuff back. I'm still going to fight for it. But in the meantime, I'm going to get real cold. Okay? So if I have ClO, I've taken 2 oxygens away. It becomes hypochlorite. I can do that with all of them. That's another 10 that I can name. Well, what if we go the other way? Because now if I take another one away, it just becomes chlorine, right? So if I go the other way, if I add 1 more oxygen to everything that's up there, and I'm sorry for those of you that are cat lovers, I'm a dog lover. Cats, they have their place. They can catch mice in the barn, and that's fine. But inside, they're not much use other than a companion to pet, right? At least dogs will fetch things for you. Cats will just look at you and go, hey, yeah, whatever. Anyway, be what it may. You might love cats, and it's okay. If you have a cat, and they just have everything they want, they get their little cat food, and they have everything inside, and everything's nice, and you have to take care of their potty stuff, and everything's wonderful. They get the extra prince or princess treatment. They purr, right? They purr. They come over, you sit down, they sit on your lap, and they purr. Okay, so if they have more than you need, 1 more than what's up there, then you add per to the front. So if I have ClO5, it now becomes perchlorate. Guess what? The charges always stay the same. That makes it easy, right? So by doing that little trick, you've now got 40 polyatomics in your back pocket. Okay? If that works for you, great. If it doesn't, guess what? You put them on your 3x5 card, write small. Okay. Next one. We are starting into naming. Now, here at Northridge, and only at Northridge, will you hear this? And the reason why is I found over time that it's a lot easier to tell a kid, remember that's type 1 naming. Remember that's type 2 naming. Remember that's type 3 naming. Or remember that's type 4 naming. Rather than saying, remember that's an ionic compound naming. And what kind of ionic compound naming is that? It's just a lot easier to say, that's type 1, remember? What do we do with type 1? So I'm breaking it up for you into type 1 and type 2 in this ionic compound group. So type 1 is where the charge does not change on the metal ion. Okay, it is the S block, not including hydrogen. So the first column, lithium's column, +1, always. Does not have another charge. Second column, beryllium, +2, always. Does not have another charge. And then there's what I call the slide. The slide starts at boron and aluminum and gallium, all +3. Then it goes to zinc, +2, and silver, +1. So you're sliding down. 3, 3, 3, 2, 1. Okay? Those don't change. That's just what they are. Okay? If that's just what the charge is, then I don't have to tell anything about the charge. So I can just go on to the next part, which is naming it. Okay? I have to always balance it so it equals 0. The charges always have to add to 0. Okay? No matter what I do. However many I need of each one, just like we were doing, that becomes a subscript. So if I need 3, I put that as a subscript 3. If I need 1, I don't write a 1. Okay, I just write the symbol. When I go to name it, I name the first element, then I name the second element, but then I change the ending to IDE. You guys already know how to do this. Tell me the name of this. Sodium chloride, right? That's salt, sodium chloride. What did you do? You took sodium, Na, just named it. You took chlorine, which was the second part, and you changed the ending to IDE. So you already know how to do it. Just remember that that's how you do it. So if the second number is one of those groups, one of those gangs that hang together and have a name, you don't change the ending. You just give it the way it is. So let's try some. Oh, before we try some. This is just a list to show you how you would change the name. So bromine to bromide, chlorine to chloride, fluorine to fluoride. Please no fluorides. I get a lot of kids that forget that the U is first in fluoride, not the O. Flour is down the road and around the corner in ProStart, not here. Okay, so make sure you get those right. Iodine, iodide, you can go all the way down. Oxygen, oxide, phosphorus, phosphide. So it changes a little bit towards the end. So I like this cartoon. See if you get it. Ha 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 ha. So Na and Cl, they're attracted electrostatically. It's sodium chloride, and yes, that was a salt. Okay, so let's go and do some examples. As we look at either a name or a formula, we should be able to pull everything out of it. Okay, so here we go. Sodium chloride, we just did that one. Positive ion was what? Sodium, Na, and it had a positive 1 charge, right? Negative ion was Cl, and it had a -1 charge. The chemical formula was what? NaCl. Okay, we just did that one. That's why I went through that one fast. The next one, all they gave us is Li, lowercase 3, PO4, lowercase 4. So the first thing I do is say, okay, Li, I know that's on the periodic table in the S, and I know it's in the first column. So what do I know about Li? What's its charge? +1. And it took 3 of these to balance out the PO4. So what's that tell me about PO4's charge? It's a -3. Good. PO4 has a -3 charge. Now, I know from the periodic table Li is lithium. I don't know PO4 yet because I haven't used it enough. So I look on the back of my periodic table, or I look back in my notes, and I look under the -3 column to find PO4. And what is it? Phosphate. Good. So I just write phosphate at the end. Done. Okay, on the next one, it gave me magnesium sulfide. So what is my positive ion? Magnesium. What's the symbol for magnesium? Mg. And what charge would magnesium have? Good. It's in the second column, so it has a +2. Sulfide. What element is that? Sulfur. Good. Sulfur symbol is what? S. How many does S need to make it to a noble gas? 2. Good. So I'm going to put a 2 minus. I have a 2 plus and a 2 minus. They're going to cancel out and make 0 by themselves. I don't do anything, so I just smash them together. M, G, and S. Okay, the next one, they gave me the elements in the polyatomic, but they did not give me the charge. So calcium. What's the charge on calcium? 2 plus, good. And nitrate. Or excuse me, NO3. Wasn't supposed to tell you what it was. It's a -1. Okay, now this is a problem, right? They're not going to add to 0. So what do I need to do? I need 2 nitrates, but nitrate is a group. So remember, if it's a group, you're going to hold it in parentheses and tell how many you need. So I'm going to put Ca parenthesis NO3 parenthesis closed. And how many did you say I needed? 2. So I put the 2 on the outside. Okay? So how do I name it? Calcium nitrate. And we're done. All right, next one. Rb. Where's Rb? What charge is Rb going to have? +1, first column. Okay, SO3, looking on the back of my periodic table. I have no idea what it is. SO3. Sulfite. Okay, I'm going to put that name over here so I don't have to look it up again when I'm done. Sulfite. What's the charge? What's the charge? -2. Okay. All right. How many of each one do I need to make it equal 0 when it's added together? Need 2 of Rb. Okay, so I'm going to go Rb subscript 2 and then SO3. Since I did not need more than one of a group, I don't put parentheses around it. I only put parentheses if I need more than one. How do I name this? What is Rb? Rubidium. And my pen went out at the end. Sorry. Okay, so I want you to try. I know there's a lot. I want you to do at least up to 10 before you stop and go to Learn Smart. Okay? At this point, we're up in the book to 3.5. I'm going to walk around and help for a little bit, and then I'm going to put the answers on the board for 1 through 10 that are on the board. There are more if you want to keep doing them. Remember that the study guide is for you. It's not to be turned in. It's to help you to be prepared for the test. So if you still aren't getting it at 10 and still struggling, keep going. Okay? If you're getting it at 10 and you don't, and you want to stop and move on, move on. Okay? So I'm going to walk around. If you need help, holler. Once I make one walk around, I'm going to put the answers up for 1 through 10, so don't look up at the board until you're ready to have answers given you. So this is sulfur.
Yeah.
So it's an element, so it's going to go to sulfide.
Yeah. Okay.
always get that wrong. It's A. Okay, so it's all up on the board. When you are done with up through 10, or if you want to just check and see if you're on the right path, you can do that. But don't just copy it down. Try it on your own. See if you can get it done. I am going to stop the video at this point. I will be putting this up on your Canvas, so if you want to look back at it, you can. But we're working on Learn Smarts 3.1 and 3.2, and Learn Smart 3.3 and 3.4 at this point.